Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group L7 for SMD 3013 Geometry, and today we are presenting to you the Malaysian Cultural Arts and Geometry for our second assignment. This is our group members. Alright, so my name is Isul and I will proceed with the first part, which is the introduction. Alright, so the object or the theme we choose for this assignment is Tenunai, and the object that we choose is kain samping. Alright, so what is the samping? Samping is a traditional wrap around sarung worn around the waist over baju Melayu. It is woven by hands or machines from sarung, songket, or tenun fabric. It is originated from Malacca during the 15th century, and firstly, it was used to distinguish Malay from foreigners that trading in Malacca. Later, it is modified by Tun Hassan to better reflect Islamic principles of modesty. Today, kain samping commonly worn by men in Malaysia, Singapore, and Brunei. Okay, what is the function of samping? First, it complements baju Melayu. It covers the trousers from waist to knees for modesty. It is commonly worn during Hari Raya celebrations. It represents Malay identity, culture, and heritage. It is considered an essential part of formal Malay attire. It is also worn on Friday by the students and civil servants. It is suitable for Friday prayers and religious occasions. Alright, so size of the samping that we choose is the normal standard adult size samping. It is actually very depends on who is the user. Alright, so for this samping that we've chosen, the measurement or the value of the measurement is it has a width of 1.00 meter, length of 0.86 meter, and the area of 0.86 meters square.
The first shape that can be found in samping is square. A square is a rectangle that is having two congruent adjacent sides. Square shapes can be easily found and easily identified within the central section of the woven samping. And the square shaped petals are arranged in an orderly grid, and it is served as the framework for the decorative motif found throughout fabric. This shape contributes to a balanced, structured, and symmetrical design in the samping. The properties of the square in the samping is it has 4 equal sides and it has 4 right angles, which is 90 degrees each. The lengths of the diagonals are equal, and the diagonals cross in the center and at the right angles. The opposite sides are parallel, and it has 4 lines of symmetry. The rotational symmetry of the square is of order 4. The squares in the woven samping improve the overall symmetry of the textile design and provide an orderly arrangement for the motifs. The next shape that can be found in samping is rectangles shape. Rectangles are parallelograms with right angles, and the rectangles can be found in both the main panels and the border area. Several patterns in rectangular panels are enclosed within the woven grid structures, and this creates a harmonic pattern across the clothes. And as you can see the diagram above here, the striped area at the samping site additionally has additional rectangular component inside of it. For the properties of the rectangles has 2-dimensional geometric figure with 4 sides and 4 right angles each, which is opposite sides are equal in length and parallel. Meanwhile, the adjacent sides are unequal in length, and the diagonals are equal and intersect at the middle, and it has rotational symmetry of order 2 and 2 lines of symmetry. And therefore, rectangular panels in the woven samping helps in arranging the motifs and give the textile design a more organized appearance. This part contributes to the total symmetry of the textile design. Next, another geometric shapes that can be identified in the woven samping is a rhombus, commonly referred to as a diamond shape. In the samping, the woven shape can easily found in decorative motif within the square blocks, and these motifs are carefully woven using intersecting threads to create a symmetrical diamond-shaped patterns. Next is the properties of the rhombus. Rhombus is a 2-dimensional shape that has 4 equal sides. Unlike squares, a rhombus angle can be different from 90 degrees. The opposite sides are parallel and the diagonal intersects at right angles, while bisecting each other. The adjacent angles are also supplementary, which means it is summed to 180 degrees. And the diagonal also divide the rhombus into 4 congruent right triangles, and it has 2 lines of symmetry along the diagonals, and the rotational symmetry of the rhombus is of order 2. Therefore, the rhombus motif found in the woven samping contribute to the geometric deliberateness of the design and create a sense of balance and harmony within the overall pattern. That's all for me. Thank you.
Hi, I'm Yakisina. I would like to explain about the geometrical concept that identified from the woven samping. For number 1 geometrical concept of square, the first shape is the square. The square has a side length of 3 cm. Each side using the formula perimeter, which is 4 times the side length that we are got from side. We got the centimeter is the 12 centimeter. This means that if we trace along the outer boundary of the square motif, the total distance traveled is 12 centimeters. This demonstrates the concept of perimeter, which measures the total length around a two-dimensional shape. Next, the area of square is calculated by multiplying the side length by itself. The area obtained is 9 square, which is 3 multiplied 3, we got 9. The area represents the amount of surface enclosed within the square. In the woven stamping, this area determines the space available for decorative motifs and patterns. A larger square would provide more space for the motif, and meanwhile for the smaller square would limit the size of the motif. The square also contains 4 right angles, each measuring 19 degrees. When these angles are added together, the total is 360 degrees. This demonstrates an important geometrical concept that every quadrilateral for a total interior angle sum of 360 degrees. The presence of 4 right angles also contributes to the balanced and symmetrical appearance of the woven stamping. For 2.2.2 geometrical concept of rectangles, the second shape that we identify in the woven stamping is rectangle. We found 3 different rectangles, which have different measures. For the first rectangle, we got the length is 12.5 centimeter and the width is 3 centimeter. So by using the formula perimeter, which is length plus width, we got the perimeter is 29 centimeter. And for the area, we got the 34.5 centimeter square. We got it from the calculation length multiplied with the width. So as we know that the rectangle has a right angle for right angle. Right angle are formed when the two lines are perpendicular and intersect each other and form right angles. So to find the sum of interior right angles, we add all the angles and we got the total angle is 360 degrees. And for rectangle 2, we got the length 90 centimeter and the width is 50 centimeter. So same like other rectangles and the square, we use the same formula, which is length plus y and y. So easy for us to calculate this, we just multiply 2 with the length plus the y. So we got the perimeter is 68 centimeter, and the area also we use the same formula, which is length multiplied with y, which is 19 multiplied 15, and we got the area is 285 cm square. And same like the rectangle one, we total up the angles and we got the sum of interior angle is 360 degree. And for rectangle 3, we also have the length 90 centimeter and the width is 3 centimeter. So we calculate the perimeter, we added all the side and we got the perimeter is 44 centimeter. And for the area, we calculate using the same formula also, which is length multiply y, and we got the area is 57 centimeter square. Sum of interior angle also same, which is 360 degree. We got it from the multiplying all the interior angle, which is the right angle 19 degree. From these 3 rectangles, we can observe the relationship between the dimension, perimeter, and area. As the length and width increase, both the perimeter and area increases too. All the 3 rectangles maintain the same geometrical property, including 4 right angles, opposite sides that are equal and parallel, and interior angle sum of 360 degrees. For 2.2.3 geometrical concept of rhombus, the final shape that we found in the sample is the rhombus. The rhombus found has 4 equal sides, which is 1 centimeter. So to get the perimeter, we total up all the sides and we get 4 centimeters. This shows that the geometrical property, the all sides of a rhombus are congruent, meaning that they have the same length. Unlike the square, a rhombus does not necessarily have 4 right angles. However, its opposite angles are equal and its adjacent angles are supplementary, meaning they add up to 180 degrees. The area of the rhombus is approximately 1.13 centimeter square. The area is calculated using the length of the diagonals, like this formula, which is different from the method used for squares and rectangles. Another important concept is the diagonals of the rhombus. The diagonal intersect at the right angle and bisect each other. This demonstrates the concept of perpendicular lines that we learned in class. The rhombus also has symmetry. Its diagonal divide the shape into equal parts, creating a balanced and harmonious pattern within the woven design.
I am Muhammad Najwan and I will proceed with 2.3, which is transformation in motif and pattern. So before we proceed, transformation in mathematics usually involve 2 things, which are the motif and pattern. So in our product that we have chosen, transformation in motif means that the original object or the only sole geometry shape which becomes the starting point of the transformation. Meanwhile, transformation in pattern refers to the arrangement of the repeating geometry pattern or repeating motif that is printed across the sunbeam. So the first transformation in motif that we have chosen is translation of the floral stars. As we can see in this diagram, the floral stars located inside the square, which is repeatedly printed throughout our fabric by moving both horizontally and vertically. By a unit square of 3 cm horizontally and 3 cm vertically downwards or upwards according to the chosen motif. However, this can be extended depending where we choose our starting point of the motif and end point of the motif. Next, we have the reflection of the border of our motif. So, as we can see in our sampling, the same motif appears on the upper and lower border of the motif. The motif can be considered reflection of each other because there is axis of reflection which reflect the motif with each other. So, the only differences, however, is the color tone. Finally, the reflection will create a balanced and a symmetrical design with each other. Next, we move to the transformation in pattern. So first, we have the translation. As we can see, in our sampling, the central jacket design with floral stars and diamond inscribed in square is repeatedly printed uniformly across the sampling, which can be seen in the diagram. It can be classified as translations as it moves vertically or horizontally depending on where the starting point and the end points of our chosen translation. Next, we also have the translation of the stripe pattern. At the back side of the sampling, as we can see in the diagram here, there is a stripe pattern which can be classified as a translation because it is repeatedly printed throughout the back side of the sampling uniformly. The pattern can also move vertically across the back side of the sampling instead of horizontally. And finally, the translation will also depend on where the starting point and the end point of our pattern. Finally, we have the reflection in the pattern. So, as we can see in the upper border and the lower border of our sampling, there is actually a horizontal axis which is the point where our motif or the pattern is reflected to each other. So, the upper and lower border of decorative can contain the same motif. The lower border is also a reflection of the upper border. And they form mirror images across the horizontal axis of the sampling, which creates a symmetrical design.
For this project assignment, we have selected kain songket, which is something that is a short traditional wrap sarong worn around the waist over the baju Melayu, traditional Malay clothing. It is made of sarong, songket, or tenun fabric by hand or by machine. This sampling research explored the application of geometry in tradition by looking at its patterns, shapes, and design elements. Part A was primarily concerned with identifying and describing the geometric figures in the sampling. After a thorough research, we discovered many shapes, such as squares and rhombus. Each shape was examined minutely for its geometrical properties, such as side length, angles, symmetry, and how they were positioned in the weaving. These geometric shapes' frequent occurrence also demonstrates how mathematics concepts are incorporated into traditional cultural art. On the other hand, Part B contained the analysis on the geometric concepts and variations in the identified shapes. We measured key geometric features like perimeters, areas, and angles of the squares, rectangles, and rhombus in the sampling. Geometric transformations, particularly translation and reflection, were also considered in the study as they are evident in the pattern, borders, and motifs of the fabric. This change itself contributed to the visual balance, symmetry, and coherence of the fabric design. This particular research has proved that the woven sampling is not only an important cultural garment, but also an excellent example of the application of geometric shapes, measurements, and transformations in material objects and traditional craftsmanship. To sum up, this assignment has given us important insights into how geometry is used in common objects like the sampling. Just by observing geometrical shapes, measures, motifs, and patterns, we have also established a greater understanding of the concepts included in everyday items. Furthermore, this research taught us the application of transformations such as rotation, translation, and reflection to produce designs that are visually appealing and harmonious. This assignment also dawned on me that geometry is used greatly in everyday life, and it is not just something that is taught in classrooms. Geometric ideas are used in textiles, architecture, interior design, engineering, and many more fields. The sampling itself is a good example of how one can combine creativity and cultural traditions with mathematics. Upon completing this assignment, we have a better understanding of geometry and the rich heritage and culture rooted in traditional Malay fabrics.